Mus is selling two kinds of crisps, P and Q, with 125 ringgit for stock. It's a linear programming question. Turn each rule into a line, shade the region that obeys them all, then read off what we need. Here's what we're given. P costs 4 and sells for 10, Q costs 250 and sells for 7. X counts P packets, Y counts Q packets. And here's everything to do. 3 inequalities and region are the most P packets when 12 of Q sell, and whether the prices are good enough. So, the 2 price lists and a budget, and 5 things to determine across the parts. The horizontal axis counts packets of P, the vertical axis packets of Q. Each rule becomes a straight line. We keep the side that obeys it. Where all the kept sides overlap is region R, and the best or worst profit always sits at a corner. Part A, 4 ringgit per P packet, 250 per Q packet. Total spend can't beat the budget, so this is at most 125. Double it to clear the decimal. Call this constraint 1. To draw the boundary, set x to 0 and read y is 50. Set y to 0 and read x is 31 1/4. 2 points fix the line. Join them with a solid line and keep everything on or below it toward the origin. Part B. The given shaded region has a boundary to read. The boundary cuts both axes at 20, so its equation is x plus y equals 20. The shading sits above the line, so the rule is x plus y at least 20. Constraint 2. Part C. P sold is less than 3/2 of Q. In symbols, x is less than 3/2 y. Multiply out 2x under 3y, a strict less than, so the line is dashed. It goes through the origin and through 1510 as well, since 2 times 15 equals 3 times 10. Draw it dashed and keep the side toward the y-axis, where there's relatively more Q than P. Overlap all 3 kept sides in the first quadrant. The shape that survives is region R. Part D1. Set y to 12 and see how big x can be inside R. Draw the line y equals 12. The budget allows x up to 23.75. Staying above line 2 needs x at least 8. And the third rule caps x strictly below 18, the tightest one. Packets are whole numbers, so the most P packets is 17. Part D2. Profit per packet is selling price minus cost. P earns 6 a packet, Q earns 450. Total profit is our objective function, 6x plus 450y. Now treat this line like a ruler. Slide it across R, keeping it parallel, until the last corner it touches. We want the smallest profit, so we slide toward the origin and stop at the corner nearest it. At that corner, 1P and 19Q, the minimum profit is 91 ringgit 50. He keeps half for running costs, 45 ringgit 75. Even in the worst case, that beats the 40 ringgit wage, so the prices are suitable. Final answers. The budget gives 4x plus 250y at most 125. The shaded region is X plus Y at least 20. The third rule is X under 3 halves Y, and together they build region R. With 12 of Q, the most P packets is 17. And the minimum profit is 91.50, so half of it, 45.75, beats the 40 ringgit wage. The prices are suitable.